Okay, for problem number 2, same thing. We have an x and a y in the equation, so it's implicit. Y is not defined explicitly in terms of x, so we have to take the derivative operator of both sides. So if we take the derivative operator of this side, 5xy squared, and the derivative operator of the right side, well, the right side is just a constant, so that goes away, and that's 0. So on the left side, we have two things. We have 5x times y squared, and so we just have to use the product rule and we'll just separate this. So this is the derivative of the first, dx of 5x times the second times y squared plus the first, which is just 5x, times the derivative of the second. Okay, so the derivative of the first, 5x, is just 5. So we have 5y squared plus the first, 5x. Okay, now this part right here, this ddx of y squared, and this is the tricky part. This is the new part. ddx of y squared. And again, we apply the chain rule here, and we take the derivative of y squared with respect to y. And so that is just 2y, and then we times that by y with the derivative of y dy dx. And that's all that equals. And that's really the major part of this implicit differentiation, dy dx. Okay, so if we multiply this by 2y, dy dx is equal to 0. And then from that, we can solve algebraically for dy dx. So let's subtract 5y from both sides. 5y squared minus 5y squared minus 5y squared. And so that's going to give us 5x times 2y dy dx is equal to a negative 5y squared.
Okay.
And then we can divide both sides by 5x times 2y divide by 5x times 2y. This cancels, and so let's just go right up here. So we have left dy dx is equal to minus 5y squared all over 5x times 2y. And we can just clean this up. The 5's will cancel, and this y will cancel with one of these y's, and so we're left with negative y over 2x. And that is your answer, dy dx. And I realize I went kind of fast, but the whole key is this derivative operator when you have a y. And you just take the derivative with respect to y squared is 2y, and then you multiply that by dy dx. And that dy dx then is what we are trying to find in our original problem.